Alright, once again, welcome to the Saturday class. This week we'll be doing random access files as well as sequential files, starting off first sequential files. And I'll be giving you guys a quick overview of files and then we'll go for it, right? Yeah, so files are actually quite cool. Calculations through files as well. Alright, we'll definitely Mr. Cottrell did tell me, or Dr. Cottrell now, did tell me to sort out two past papers. So I've chosen the 2012 and 2013 past papers that you guys have access to, and we'll be walking through those. But I just want to talk a little bit more about what files are and how they work, right? So that we can kind of get an idea of what we're trying to do and why, right? So I think that's very important. Like it's just that underlying understanding that I think might be worth something. All right, so let's just try and share a screen. All right, so what I want you guys to imagine, right, is that let's say this is a file, right? And the side here is some stuff. Say the information looks like this, right? That's how it looks in a real file. It's actually just stored in binary. Um, and this whole file is full of that stuff, right? This is how it actually looks in memory. But when you want Visual Studio to access it, you can give access to this file in two ways. And you can give Visual Studio access to this file as a sequential file, or you can give it access as a random access file, right? And a random access file has one characteristic that a sequential file doesn't. It's that this file here is separated into other little blocks, right? For however big a record is. That's a random access file. So you can go record 1, record 2, etc., 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 right? So, for example, that's because you make the file this length when you create it, and you give space for each record. Whilst with a sequential file, you don't necessarily give space for that. You just serialize a actual thing. So you actually serialize a whole class. So it handles where the start and end are. You don't handle where the start and end are. So in a sequential file, it can look something like this. Like you can have record 2, and then you can have like record 3 here, right? And then the problem with this is because I don't know where this ends. I can't index in here. I can't say, well, 3 times the size of record 1 will give me record 3 or whatever the case might be, right? It's never gonna work in a sequential file because because the computer is handling where to save everything, where stuff ends, where your record ends. That's what serializable does, right? So that's why you set up a serializable class and you serialize that class, and that's how it saves those classes or instances of those classes to the file. So that's essentially like the difference between a sequential file and a random access file. And the biggest difference is essentially that when you start, so sequential file means you can start at the top and work your way down. That's the only way it can work, right? While random access means you can actually start on the side, and you'll know exactly you can start like say at record 3 and work your way down, or you can get only record 3 out of it because you know where it will be. in the order that it is in, right? As you can see, if in random access files, sometimes there's like quote unquote unused space, right? So that's something you'll have to consider. Obviously, different file accesses are great for different different things. So if you're talking about like something that you index into, like a really large file with like thousands of records, it obviously makes more sense for it to be a random access file. If you're only going to be looking for one specific thing, but if you're looping through all of those thousand over and over again, then it just makes more sense to be a sequential file. All right, I'm hoping that kind of helped you guys understand files just a little bit. I will be now going on to actually coding it out. You guys happy with that? Yes, no, maybe? Okay, cool. That's great. That's quite cool. Yeah. Okay, let's try and start up Visual Studio. Any questions with regards to that, like that what I've explained so far? No? Okay, cool. That's great. Just trying to find what I was looking for. So what we're going to be doing is we're going to be doing essentially the firefighter. So so for a record of unknown values, is it better to use a sequential file? Yes, yes. If you don't know the size of something, then it's probably best to use a sequential file to save it, because then Visual Studio will handle it for you. But most likely in your test, we won't give you the option. We'll tell you which one you're supposed to be doing, and you'll have to be doing that one, right? That's just unlucky the way it's going to be. So do you guys remember the firefighter practical? Inside in there where we had to have like different kinds of firefighters, right? So that was actually a past paper. I think it was 2012. I'm not sure, but yeah. So that's the one that we'll be starting with. So it was the actual like the Saturday class tutorial was the 12th of the 9th, if I'm not mistaken. So I'm just gonna pull up that one, and we'll start off with. So I've already explained like how the classes work. So essentially, I think that's the best one to teach you files with, because you understand the structure of it. You've already had a Saturday tutorial on it, so you don't have to be stressed about anything else other than the files, right? I think that's a great idea. So that's why that one was chosen. Let's just share screen again. All right, so if you guys look at it, this is exactly the same thing that I've done with you guys. Adjust your details. You have to do your option statements. In a firefighter, there's like call sign, experience, and years. In the constructor, we call add experience times 0.75, all of that, right? So that's 100% definitely that's 100% definitely the practical we were doing. And actually, I was just trying to open that. I think it's either 2012. Oh, let me try and find the question paper also. Yes. So it is the 2012 one, right? So if I could just show you guys. So the 2012 past paper that you guys have access to on Eve, right? The 2019 October 2012 paper. If you look at it, it's all about the fire station. We've got call sign, experience, years, ad experience, display, and the constructor that does the ad experience. And you got these two different ones. You got CER and CEnviro, which we've done already, right? We've done the ad experience for this one. We know that the subroutine here multiplies the level of firefighters first aid by 15. We know that this one here is actually the product of the existing experience and the chemistry level. And now, and we've done the single array and the multi-line text box to actually display it, right? So all of that has been done. But now afterwards, there is a file section in the actual past paper that you guys didn't have in the practical. And that's kind of what we'll be really looking at, right? So in here, what it says is make use of a dynamic array, save of the firefighter objects, and save all of the CEnviro objects to a sequential file. This with the same name as the project name, and this other file extension IFM. For example, student 201201 sitting at computer 10 would have his name as CO10 or C010 2012, many zeros and one, right? So the name of the sequential file will be like that. But we don't have this kind of scenario. You guys don't have assigned computers this year, so you guys at home. So you could just kind of put your student number down and go .ifm, I guess, when you're practicing this one. Obviously, the instructions will be more relative to you guys in your actual test, right? So you may assume that the file is saved in the location or in the location folder of the Visual Studio application. You may also create the file and save all of the CEnviro objects without having to create, close, and open the file again. Right now, that's really important, right? What that means is you don't have to do try catches and if the file doesn't exist and stuff like that, right? Which is super cool. It means that we don't have to really care about error handling there so much, and that it's essentially just makes our lives a lot easier, right? If you've already done the try catch stuff, then you'll know how much easier it kind of makes it, right? So yeah, that's just the thing. This is just for my reference so that I don't teach you guys anything wrong. I'll put it here. Yeah. All right. So from here, what you can kind of tell is we need to do all of this in the form. So let's look at what we've got done in the form already, right? So in the form, we've got the firefighters array, we've got the number here, but we're not going to be relying on that to write our file. We do ask for all of this information in a very nice way. We do our whole environment of new line with the cases. One of the things I did notice in your practical from last week is that you guys are using cases even when you don't need to. Like even when there's composition, there's only one kind of class that you guys are doing. You guys are still using like cases, and it's the weirdest thing to me. But I guess that's you guys. A lot of people aren't really super keen to learn how to do this, I guess, and that can be a problem. But it's not going to be my problem essentially. But yeah, so that's the thing. Okay, cool. So now that we know that's what's going on with the input, then you can say using polymorphism, right? So this is where we do the add experience and then we do the dot display. Then we say, okay, cool, place it into the text with the place text function. And then we've got a type counting situation here, and we've got some cool stuff going on there with like display, right? I remember this was we had to do a bit of debugging here with the type off kind of thing. That was pretty cool. And then we've got a use grid to display the chem level for all CEnviros. So then what we do is we downcast them from the array. And once we downcast them, then we count them and we go at it, right? So we put it into a new array and then we work with it. So that's a pretty that's essentially the whole of the non-file section done. Does anybody have any questions regarding that? Like I told you guys, it was on the 12th of September that we did it, so it was uploaded on around the 14th. You guys can go and watch that Saturday tutorial again, and you can kind of look at that and decide how you want to go at it, or how you want, or if you're not quite sure how it's supposed to work. That's definitely an option. You can just kind of go, okay, cool, and then work with it, right? So in this question paper, right, one of the things that they definitely say is we're only supposed to save the CEnviro objects, right? Not all of the C firefighters. So clearly we'll have to be doing some type of checking, right? So that's one of the first things that we have to do. So let's start off by putting down a button save on our form. If nobody has any questions so far, I'll give you guys a minute quickly. No questions? All right, cool. Let's get this party started. It's a party, I don't know. Am I correct to say that we will have the if statements and direct cost? Yes, you will definitely have if statements and a direct cost. So similar to how we did the different chemical levels, right? Because what we had to do is you had to down cost. So we said we'll create an array, then we're gonna go and loop through it and say if the type of fighters is that, then we're gonna direct cost it, shove it into that array, then go through that array and go, all right, cool. These are all of my CEnvironment dudes. Let's save them to a file, right? That's kind of how it's gonna work. So very similar to the counting the number of the different type thing. And I think that's kind of why that was the previous question. So can I explain? Okay, cool. Let's talk about the upcasting, right? Um, Upcasting happens in my input section. So what happens is first I go through it and I say, well, how many fighters are there, right? Then I rename the array, so I make space for all of the firefighters. Then I start looping through the firefighters and I go, well, the first thing I'm gonna do is I'm gonna make a type and I'm gonna get the type of the firefighter, right? So either 1, 2, or 3. All firefighters have a call sign and all firefighters have a year. So once we know that, then we can just go, give me your call sign, give me your year for this firefighter here. And then if it's a type 1 firefighter, then we just have to go, well, create that firefighter, add the call sign, and set the firefighter to the firefighter array. In the event that it's not firefighter 1, it's an ER, then what we do is we're going to say, well, we're going to define a new ER with the number of years because we've got those. Set the call sign and set the first aid level, and we'll be asking for this first aid level. Then at the end here, this is where the upcasting happens. Here's where we say, all right, this is an array of firefighters, but I'm going to shove a CER in, right? The same thing happens with the CEnviro. I add fighter 3 to this, and fighter 3 is definitely a CEnviro, right? And that works because of polymorphism. So the only time you should be having this kind of upcasting going on is when you've got an inheritance hierarchy, right? If you don't have inheritance, you shouldn't be doing this. The upcasting specifically. All right, cool. So let's go back to naming that button. I'm hoping that answered your question. Okay, cool. Sorry about that, guys. I think I disconnected there for a second. I have no idea why. It was the weirdest thing. All I was saying was just don't forget to rename your stuff, your buttons, forms, etc. Right, so we'll have a nice little save scene via object here. Double click on it, and in here, right, the first thing we need to know is how many are we saving, right? So we're gonna just copy paste this because it's easier for us. So in terms of assigning values to a variable, am I correct to say that the left-hand variable is the one that gets the value being assigned? All right, let me quickly show you about that. That's something that you probably should know from earlier, but I don't judge. So we'll go back to Lucidchart here, right? And what we'll do is we'll say this is a variable, it's a box, right? We'll say it's variable A. Right, it's named variable A. Um, inside it we have some stuff. We'll have a cloud in this variable, right? Because you can store anything in a variable. In variable B, we will have variable B. We will have a star because you can put anything in a variable, right? So let's just make this a bit bigger because it's not fitting our star. Right? And then what I want to do is I want to assign variable A to variable B, right? So when that happens, I want to go variable A equals variable B. Right, now what you can look at here is you can say this equals can actually look like an arrow, right? It goes variable B gets put into A, right? So what that's essentially doing is it's going take this that you've discovered, oh well, that you've kind of created now, right? And go put it next to each other. Right, and then we're gonna go and move what was in here into here and Control C. And that's how to look now. Right, does that make sense? So what's on the left gets the value from what's on the right. So that answers your question, I'm hoping. All right, cool. Back to work. Okay, so let's see what we've done so far in our button save. We've got some array that we've created of scene arrows. We've got the number of these guys, and then we've kind of dimmed x as an integer. We started it off at 1. We went, if this is that, increase the size, read and preserve it to make it bigger, and then direct cast it and put something in. Right, so what we've got at the end is we've got some array and we've got some number of them, right? So that's really important. So let's just write down what we have here. We have an array of enviros. What is the purpose of read and preserve? Well, you see, every time I don't know how many enviros there are in the array. I didn't record that, right, when I was starting this program. I didn't record the number of enviros. So I have to count those. I can't just make an array of size 30 and then have too much extra. I can't make one of size 5 and then skip some, right? So what I have to do is I have to, as we get one more, I have to make one more space in the array. But while I'm making that extra space in the array, I can't lose the stuff I saved previously, right? And that's what preserve means. Preserve will keep the stuff that was already put into the array. Does that make sense? Alright, so now that we know that, we can start with the actual file stuff. So the first step on a sequential file is we're going to create a file stream, right? So it's step one. We're going to say, well, gum first as a file stream. Right? And we're going to say equals to new file stream. Then the access mode we're going to use is, so we'll have to put a file name in here, right? File name would probably have been some constant. So let's make a constant quickly up here, where we can kind of save it. Right, and inside the file name we'll have some cool stuff, right? So that's gonna have the path. So or in our case, because we want to save it directly to the root folder, we don't really specify a path, right? So what we're gonna do is we're gonna say, well, private file name as string, right? Semicolons here, and then we go and I go, I don't know, let's just put my file, right? Item. So now I got that, which is quite cool. We can go, file name is the first parameter here. Once you've got file name, then what it asks for is an access type, right? So we can go file access dot, and then it's read write, right? So obviously we're trying to write, okay? That's just the first thing that you have to know. It's going to be file access dot write. But we also want the version with the 3 parameters, right? Because we want to specify that we can create the file if it doesn't exist. And this one is going to be called file mode, right? Creates. So that's what that does. So what this line does is says, go and look inside your root folder of this project and go and find something with the name myfile.txt .ifm, right? And if there's nothing there, create it. And when you've created it, open it up with write access, so we can write to it, right? That's the file stream. How do you make your Visual Studio show you a list of parameters and you code any function on keyboard? You just press Control Space, right? So, like, let's say I wanted to see what is going on here. If it doesn't do it, I'll be the saddest person, right? So once I do that, I can go like that, right? And then I just press Control Space and it goes, okay, cool. File system handlers. We'll need a handle. We'll need access, and we'll need own thing, right? And that's not necessarily the one we're trying to look for. We want the file mode one, right? And then it'll just know, you'll just know that that's how it's supposed to work. This relies a lot on you knowing the different inbuilt functions of the IO stream, right? IO stream is something that gets imported the minute I type out file stream, as you can see, right? That wasn't there before, but yeah. So you need to know your stuff when you're doing that one, right? That's really important there. So now we've got, we create a file stream. Then what we're going to do is the next thing we need is a binary formatter, right? Now, whenever you create a binary formatter, you need to have something that's serializable. So let's go to our class and make it serializable. Right, now that it's serializable, we can actually write it to the file. What this means is we're telling the computer to handle when this starts and when the record ends. Do you guys remember that? When I was explaining like how a sequential file works, we're making sure that Visual Studio handles that for us. We're not trying to handle it on our own. So let's turn ourselves a binary formatter. It's a binary formatter. right? And this is just going to be blank for now. Very cool. And then what we're going to do is we're going to say, let's loop through it, right? So this is supposed to be step 2. I'm supposed to check this out. Step 2, formatter, and set the class being saved to serializable, right? And step 3 is now to start writing. Okay, so already got x up here, so I'm just gonna go x equals to 1. Don't have to. Okay, wait. Actually, let's not do that. So it's easy and readable. Right, and then what we do is we go bf dot serialize fs. So where are we serializing to, and what are we serializing? We are serializing environs. Environs are y. Right now, the key thing with this whole thing is you'll see that this is in green. It says variable environs is used before it has been assigned a value, right? And that means if there's no environs in our actual the total array, then what's going to happen is this is going to bomb out and it's going to crash, right? So from this, we know. Okay, well, first let's close our file stream. We know that that's the next step. Close fs and delete bf, right? So first I like to do it in the opposite way that I started. So bf dot close is it? No, it's not. So it's just going to be bf equals to nothing. Right, so we deleted the bf, and then we're gonna now close the file stream. So fs dot dash fs dot close fs equals to nothing. Right. Now we've handled everything. Okay. But now all of this stuff here only works if there's environs. So I'm gonna cut it. I'm gonna go if environs greater than 0. I'm gonna put that in there. Right. So number of errors starts at 0. So it only hits 1 if we've got at least 1. And that'll stop this from causing an error. Right? Does that make sense? Everybody? Yes? No? Maybe not? Maybe? Okay, cool. So now that we've saved to the file, the next step is clearly going to be a reading from the file. Right? Now, what do we have to do when we read from the file here? Wants to know the average. So now what we'll have to do is we'll have to read it out and make an average, right? So I think that's going to be that what you're talking about, a calculation with a file, right? And an average is a really good example of why you need a sequential file. You can only use a sequential file would be the best option to kind of work with this, because for an average you have to kind of loop through every single one of the objects in the file, right? And that's why it just makes more sense to have a sequential file for this calculation. If you had a different kind of calculation, you would definitely be using a random access file instead. All right. So that's just a little bit of wisdom for you in your next journey, right? So we're getting the average experience of all of the scene viral objects. So let's go put on a button as usual. And we'll be here to say read average right in here. Now, like with this one here, the first step was obviously to now create this file stream in the binary format. But also, we know we're going to be saving these at some stage, right? So what we have to do is we're going to have these, and let's pop those down here along with these, because we know that that's going to be first steps, right? So now that we've got our file stream and our binary formatter, what you can kind of do is you can go, well, while the fs dot position less than fs, then yeah, the file mode. I was about to get to that now. So what he's talking about there is I'm doing a create here. It's not supposed to be create, it's supposed to be open. Right? So that's the problem with copy pasting. Don't do it in your test. You'll have a problem. Right? And also it's not read right here, it's read. So that's the other thing. Yes, thank you. There we go. So only copy and paste if you know exactly what's supposed to be everywhere. And then once you know this, we can go, okay, let's demo ourselves an enviro. N is going to be equal to direct cost, F, serialize, FS, and C enviro. Right? And what we've done so far is we've kind of we've got the environment object out, right? But now we need to put it into the array. So we're gonna go. But now we need to read and preserve this first. So read and preserve. Wait, let's think about this, guys. Firstly, we need to update the number, right? So first we're going to update the num enviros equals 1, right? And then we're going to read and preserve like we did up here. So what we did up here was we went read and preserve enviros to num enviros, and that's going to be the same thing. It's going to be exactly the same thing. We can actually just kind of copy that. Right, and what this does is inside here, while it's reading, every time it reads 1, it's going to increase that, increase the array size, and drop it in here. Right, and so now we have to drop it in. So we're going to go but let's see, can we actually do it like that? Because this was num enviros. Yes, we can. So num enviros equals 2, and then we're going to go in. Now we have an array saved from the file, right? So now that we have the array, we can do the next step, which was get the average, right? And that's essentially going to be a for loop. So for x as 1, 2. Virus, next X. Let's do my total here quickly. This might be a double. Right? And it is now perfectly fine. And remember, we can only do this if there's more than one of these. So you might want to put it in a little if statement there, but you don't have to because it's not going to crash when you test it like that, right? So now we got the total and then we got the average. Let's see what does the question paper actually say. It says read the above. Reopen the sequential reopen the sequential file in question E above. Read the CEnviro objects. In a single line text box, display the average experience of all of the CEnviro objects. All right, cool. So back here, we're gonna go form, put a text box down. That doesn't look as cool. I think this is big enough. And we just call this txt average. Right, and in here, what we'll do is we'll go, all right, cool. Now we got the total txt average dot text is equal to c string total divided by num values. And this will 110% work. All right, cool. So now onto random access files. Yes, you can speak to me by unmuting or you can type, whichever one.
So I wanted to ask, like, do we have to create an array when deserializing?
No, you don't. You can kind of just do this total thing in there in the while loop if you wanted to. I just thought it would be easier for you guys to understand the file stuff when it's separate to the average stuff, if you get what I'm saying.
Or would it still work like if we put the total within there, then after
Yeah,
the while loop we just divide by the number of enviros?
yeah, that will work perfectly fine, right? So you could totally do something like this. You could totally do, you totally go total plus equals en dot experience, right? And that's going to work perfectly. So then you can kind of cancel out this whole situation there, right? And it's going to work and you'll get a total.
Oh, so every time you call the deserialize function, it goes to the next position automatically?
Yes,
Oh, thank you, sir.
no problem. Because each time you call the deserialize, it creates a new version of this, if it's possible. And how do you know it's possible? It's because the length hasn't been reached yet. So that's just kind of how that works. Does that make sense to everybody? Any questions? Any other questions regarding random access files? I've shown you guys how to read and write from one of them. No, yes, maybe, I don't know. And I'm not supposed to be here this week. Like I told you guys, it was my last week. But Dr. Cartel told me that some students wanted a bit of extra help, and he was wondering if I was happy to help out, and I was. So that's why I'm back. Just thought I'll quickly explain that. But yeah, so if there's no more questions, I think we can kind of go on to random access files. Is that fine? Does anybody else have any qualms with sequential files before we move on? So can you explain 192, right? Let's look at 192. 192 is here. Okay, so here's what's happening, right? So I'm creating a blank object, right? First I'm saying, I'm just making a random en that's of type CInViro, right? And what I'm doing is I'm saying, use my binary formatter's deserialize function to deserialize this file stream and to pull out exactly one CInViro from that file. The next one that we've from the last one that we done. And put it into en, right? So that's what's happening there. So what we've done is it's like me reading, it's like also saying me read one sentence from a file, right? Do you remember text files, guys? If you haven't done text files yet, then in text files just go read line, right? Because it gives you one line at a time. It's kind of the same thing. It's kind of me just going read the next line that's happening here, right? And in that from that line, turn it into a CInViro object and give it to me, right? Because this actually gives you just a random object. The deserializer just gives you some object, but because we know what we saved, we can use the CInViro. Make sense? Does it help you out a little bit? Just raise your hand if I need to like explain further, because otherwise I'm just standing here kind of awkwardly. What would you like me to explain more? You can unmute and talk to.
So can you explain from line 191 and go down?
All right, cool. So in 191, right, what I'm doing is I'm saying while the current position, right, the fs dot position is less than fs dot length, right? So what does fs position mean? Well, fs is called a file stream, right? Inside there, there's multiple different. It's a class on its own, so there's multiple different integers and doubles and stuff like that, right? That each have a name and a significance. One of the two main ones is position and length, right? So position is where we are currently in the sequential file, and length is how big the end of the file essentially, right? So what this essentially translates to is if we are not at the end of the file, right? That's kind of what this translates to. And then if we're not at the end of the file, what we do is we create a blank version of CInViro, right? Just one for us to store something in, and we say deserialize the next object in there, right? So it's essentially saying move from this position to the next position. So if I can just kind of show you in this, right? So in here, right? So in here, the file position is where we are at the time. Let's say we read the first one, right? Our file position is going to be records 2, but the end is still somewhere down here, right? So if we know where our file position is, we can kind of, okay, well, this one, it's a sequential file, so this should be up here. But yeah, so let's say we know that our file position is currently at this point here, right? If we know that it's at that point there, we know we can deserialize one object afterwards, and it will deserialize record 3 for us. And once we got that, we want to direct cast it into a CInViro, right?
Hello?
Dude, you have to mute your mic if you're going to be taking a call.
Okay, sure.
Dude, next time it's a bit wise to probably mute your mic if you're going to take a phone call. Yeah, so just a key note there. But yeah, so the file position would be here, and then we'd be able to read record 3. But once we read it with the binary formatter, what we get is an object. So you'll have to cast it into the actual correct form that it is, and that's a CInViro. Okay, yeah. So we're just doing it continuously, so it's easier to do it in a loop than rather using an if statement, if that makes sense. Okay, cool. I'm hoping that helped everybody out, and everybody now understands sequential files, and they'll ace it in their test if we have sequential files. Because if you guys ace it, it makes it easier for me to mark, and I do less work. All right. So please ace the stuff. Please study. Please study. It's okay. It's cool. It happens to everybody. But yeah. So it's just next time. Just remember. All right. Okay, cool. So that's it for sequential files. If nobody has any more questions or has any more problems, we can move on to random access, and I think I'm happy with that, right? Are you guys happy? Random access is a bit of a rough one, so I'm gonna go drink some water while you guys start up your next Visual Studio thing and code with me or whatever the case might be. We're gonna be looking at the same project that I did in the second revision session of the bootcamp, right? Do you guys remember that one with the stadiums, essentially? So yes, what's up?
So can I ask, when do we actually close the file stream, like when saving and when reading from the file?
Okay, well, for reading, for writing especially, it's important that you close the file almost immediately afterwards. Otherwise, you probably will run into an issue and not be able to to read off the file again, because if the file is still open to this project, it's like have you ever tried to copy a file that was still open or cut a file that's still open in Adobe? It just doesn't want to go anywhere, right? That's because the file is open. But Visual Studio has been very nice to you guys, and it will kind of close and flush for you guys. But in the event that you don't, you can kind of just go in here, right? You can kind of go, well, end of while. Now we've read everything, so we can go fs.close and ef dot equals nothing. So we just equal that to nothing. Right, and we can null those things. Just hang up any loose ends. So closing the file so that we can write to it again or read from it again.
So
Make
if we were
sense?
to, okay, sorry.
Yeah.
So
The next question.
if we were to close the file stream within the while loop, it would just bring back the same value,
Yes.
the same file position.
It might not, right? I've never done that because that sounds like a terrible idea. But you can experiment with that and you can try it out and tell me what happens. But what I know the file stream that close does is on your operating system, right? There's a table that talks about all of the files that are busy, so that two things can't write to the file at the same time. Now, if you have a file open, for the next person to open it, you have to close it on your end. So all you're doing is setting that flag to closed, right? So it's not that you're not busy with that file. So that's essentially what I know .close does. But I have never tried putting it in a while loop and seeing what it does. You're welcome to try that and let me know what happens. I'm really interested to see what happens there. But yeah,
Because,
does that kind of answer? Yeah.
because with last week's practical, I tried putting it within the while loop, and it kept on giving me the same answer, like when I was trying to get the average. Because it's kind of like it was
Oh,
adding the same thing again and again. So it seemed like it was going back to the first file position every single time.
okay. That would actually make quite a lot of sense, because think about it like this, right? Every time you close the file, what you're doing is you're resetting the position also. So that goes straight back to 0. You get what I'm saying?
Yes, sir.
Yeah, so that would make sense. But I've never done that before. That's an interesting one. I guess I learned something in today's Saturday class too. Okay, cool. So any further questions regarding sequential files? I really want you guys to ace this if it comes out. Please go and look at the Saturday Tata on the 12th of September, the 14th of September that it's been uploaded on. I think it's tutorial 8, if I'm not mistaken. Saturday tutorial 8. Yeah, it is Saturday Tat 8. And then you guys can kind of look at this and then understand the whole structure behind it. Go code it out from scratch, right? Go ahead and try this paper. You've got access to the paper. Try the paper and mark yourself according to the actual to the videos I've done. Like if you do that, then you get 100%, you'll definitely do pretty well in your semester test. Like you'll at least pass it, and that's what's important, right? So I'm gonna go drink some water. I'll give you guys like a 2-minute break. Does anybody have any questions before I leave? Nope. Okay, cool. No problem. So I'll be right back. You guys take a small break, start up your next Visual Studio project, and we'll go from there. All right. I am back. Let us begin with the next round. All right. Should be boot camp. Boot camp session 1, boot camp session 2. Yeah, that should work. I'm coming. I'm coming. Yes, speak to me. What's up?
So to go back to what you just explained, but I just want to have clarity, sir.
Yeah.
About the while loop, what makes the loop to stop or to end? FS,
All
the
right.
position.
Yeah, so when the FS position, so what the FS position actually is, it is the number of bytes that you've read already, right? So when the number of bytes that you've read already becomes as big as the file itself, then it stops. Does that make sense? No problem. Cool. Can everybody hear me? I think I went a bit soft there. I'm not mistaken. I'm not sure. Just raise your hand if you can hear me clearly. Okay, cool. Thank you so much. All right, cool. So this is the 2013 paper. And what this is talking about is intergalactic games, right? So the stadiums. I'm sure you guys remember me doing this in the boot camp if you guys did watch that video. If not, it's the second session of the revision boot camp. So you guys can go and watch that and just see how I did the composition and stuff like that, right? So we skipped the file section in the last one, right? And we did it via normal input, right? So let's see what we were supposed to be doing. Let's take a look at what we were supposed to be doing. I just wanna open my reference here because I did walk through this already, so I don't treat you guys badly, I guess. I teach you guys the wrong stuff. It's always a problem, right? Okay, cool. So let's read what we're supposed to do. The following questions A to C must be completed working with files. Failure to do so will result in the student being awarded 0 for the section below. Any code pertaining to incorrect file type will also be given 0. So that means if you use the sequential file, you'll be given 0. It's advised that file-related code is developed in your form class. You may assume that no collision will take place. Collisions, what that means is, let's say you mod the key and it gives you something that's already been done. How will you handle the collision? And you don't have to stress about that here, right? So obviously you'd use something like bucket handling or whatever the case might be, but I don't know if you guys have learned that yet. So firstly, we're going to create a facility record structure that will represent data on a facility. In here, it is an ID, a name, lockers, popularity. Right. A key thing to note is that this is 20 characters long. Right. That's really important. We know that the ID is from 0 to 100. We know that there's lockers, which is a Boolean, and we know that there's popularity, which is also 0 to 100. Once you've created the record structure, it says create a random access file that will store a maximum of 30 facility records, right? So it will store a maximum of 30, right? So what we can do is we can say 0 to 29, and that will be 30, and then we can mod around that, right? So you'll understand what I'm talking about mod down now. Yeah, so then the file must have the same name as your project name with the file extension .ifm, right? So, for example, blah, 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 we've done that before. Then they're talking about a hash function, right? Now what the hash function does is it'll given a record key, it'll return the byte position. Now that's something that's really, really cool. Like, do you guys remember I was talking about how file position is actually in bytes? Well, here we manage that. We don't let the file manage the position. We do it ourselves using this hashing function. So that's a cool thing there. Using this hash function developed in C, provide code that allows users to save a number of facility records into your random access file. This is using the hash function to save, right? Then write a function that will use a record key parameter to return the relevant record from the random access file. This function should return a facility rec containing data that will be used to retrieve a facility rec data in question H. Right, if we look at if G H, this is how you instantiate your stadium. So while we asked for input, you technically were supposed to do it via the file here. Okay, so any questions with regards to what they want from us here before we start coding? Does anybody not understand what's happening? Okay, so I'm gonna take it as everybody kind of knows what's expected of them if they get a question exactly like this. All right, then the questions come through.
So,
yes.
My question is with regards to the hash function.
Yeah.
Let's say you have a record number, say, of maybe, let's say, I don't know, 80, and then the nearest time number, say, it's like 1 added, not a number less than, but then like a number that is greater than that. specific number, just divided by 1. Do you take that one, or you go for the nearest one that is less than that 80 or that specific record number?
I think that kind of depends on what you were taught, because you can do it differently and still kind of be correct. But it's best for you to follow what Mr. Cottrell or Dr. Cottrell said in that regard, because I could have been taught something completely different there.
They taught
I
us
think
to
it's, yeah,
take
he said less than. He said less than. So rather just go with less than. Yeah, sorry about that. Because I could have it depends who taught you, and what they said to you, and you might have different answers there. So that's just kind of the thing, because it's all about how well you handle the maths, right? So do you understand how the modding function works, guys? Oh, or the hash function. What you're actually doing with that? Do you understand? Okay, cool. So you could essentially just use 30, but then you would have a lot of collisions, and to try and limit that a little bit, you use a prime number. So that's essentially what's happening there. So there we go. Sorry, I can't answer that one. That one's a bit of a weird one. That just kind of depends. Okay, cool. So yes, and to answer the question in the chat, random access files do usually work with a record structure because we're not serializing a class, right? So we have to make our own structure to hold something, and we need to know how big that structure is, right? And that's why it works very well with a record structure. So let's no problem. So let's just think about this, right? So how do I do that 20 character limit thing again? Does anybody know how to declare a 20 character limit? All right, let's just make the record structure quickly. Right. Right, and in here, what we need is obviously go something like this. That goes. And it is cool. All right, so let's talk about the this record structure and how big it's gonna be, right? So a couple of things that's important to remember there is a char or any character is 2 bytes, right? We know IDs are 4 bytes, and we know booleans are 2 bytes, right? So overall, we've got 20 characters, which is 40. We've got an ID, which is 4, so 44. We've got popularity, which is an integer of 4, so 48. And lockers is 2, so this is going to be 50 bytes in each record. Right? So now we know how big it is in our record. Right? Now that we've created that, right? So we've got the ID, the name, the lockers, and the popularity. Now we're going to have to create a random access file that will store a maximum of 30 facility records. And the file must have the same name as your project, blah blah blah. So let's first make a file location or file name, because we clearly need that, right? That's a constant that we usually do. So private file name string equals to fm, right? So now I got the file name down. Now I think we have to actually save some stuff to it, right? So the first thing is going to be going, well, so the integer is 4, the string is 20 times 2, the other integer is 4, and the boolean is 2. Yes, that is totally correct. Think of boolean as a single switch between either 0 or 1, and then that's kind of how it might be a chop. I'm just using 2 for now. It will work with 2, and you'll see why later on. But like the first thing that you have to do you guys remember what it is? We have to create an empty record. Right? We have to create an empty record. Once we've created the empty record, then we have to write it out 30 times. Yeah, the blank record. So that's the next thing we have to create. So first we're gonna go space. It's my space holder. Private. Empty rec. Facility rec. Right, and we'll need a subroutine here to initialize it. Right, so in this one here, what we're going to have is private sub initialize, right? And in here, what we're going to do is just going to go empty rec dot id equals to -1 empty rec dot name equals it's blank empty rec dot lockers equals true empty rec dot popularity, I think it was the last one, right? Yeah, popularity equals to -1. I'm gonna change the name here. It's just a running joke I have. I always use the word kohaku instead of empty. It's an anime reference, actually. Kind of a geek. So, yeah. If anybody here knows No Game No Life, they'll understand why I use kohaku. Right, and that should work. Shouldn't have 20 characters. Yes, I think maybe you are right. So let's use an else set there. What do you guys say? We can obviously go and actually type out 20 characters, but I'm too lazy for that. So we're gonna go else set. Alright, cool. So then that's done. That's our empty string, right? Then now the first thing we have to do is create a file. So when we're creating the file, we'll make a subroutine for creating the file. Right. As usual, the first thing we do, first step is create file stream. Second step, create binary writer. Third step, calculate length. Right. Then we're gonna write to the file. Write empties to the file. Then we're gonna flush. Then close fs nothing writer. Alright, so that's what we have to do in our create function here. Right. So firstly, we're gonna say the file stream equals to new file stream, and here obviously file name as usual, file mode that creates, and file access that writes. Right, has anybody spotted any problems yet? It's been many years since I've done random access files, so please let me know. New binary writer. This one is different from a binary formatter and we send it to FS. Right? So I think I shouldn't name this FS. It might cause problems later on, so let's put FS here. That's going to be a bit easier for everybody to understand. Alright, so now when we calculate and set the length, right, we know that the record length is 50 bytes, right? We know that there's going to be a maximum of 30. So we're going to say, well, record size is 50, max records 30, therefore and we're gonna go 30 times 50. Right, and now we've set the length. Now we're gonna write some empties to the file. Twenty-nine, right? 0 to 29. So all 30, we're gonna go to fs.seek. What does seek do? Seek goes to the position you specify, right? And we say r, x times 50, and we're going to seek it away from origin. So from the beginning, right? And then now we're going to write. So we're going to go w writes The order in which you do this is really important, by the way. You have to remember it. Right, that covers all of that. Now we flush. Always flush. And we close. And we null the writer. And that is how we create a file. What you can also do in here is you can kind of just call, because it's the only time we will ever actually use proc, right? So that just kind of makes our lives easier. So we only have to call one function, and then one will handle the other stuff for us. Right. So our next mission is to make the hashing function so we can create a save and a we can create a save. What's it called? Do we import for binary writer? No, Visual Studio does it for you. So the minute you go binary W and you press Control Space Enter, it goes and it goes, oh, we need system.io, and then it adds it for you. So that's the thing. There was a whole thing where at one stage you had to go systems.io.binary writer, right? But Visual Studio 2019 handles it quite nicely now. Yeah, Visual Studio 2019 is much better than what I wrote my paper on. So you should be grateful. You should be forever grateful. And you should thank yourself. You should thank the Lord every day that you got into the time you got into, because some of the stuff we had to do, guys. Even in Infos 2, there's a lot of drag and drop now. Back when yeah, so it's hectic. It's hectic, man. But yeah, so let's do our hash now. Alright, what do we need? Val key as integer. What's it gonna return? Another integer. Right. Okay, I'm just gonna go key. There we go. That's what I wanted. 39 is gonna be our nearest value, the easiest one to use. And then we got 50. Okay, cool. That's our hash function done. Right. Then it's important to know like how to write something down. So what you can do is you can create a save to file that saves a single record at a time. That's actually quite a cool idea, but I don't recommend doing any extra work than you have to. Right, so let's look at what else you got, right? So let's see what you got. So you got to create a random access file that will store a maximum of 30 facility records. Done. Write a hash function. Done. Done. So A, B, and C are done. Now using the function provide code that will allow you to save a number of facility records to your random access file. Okay, cool. So we do that, but we do it with a whole lot of them. So we're gonna maybe do it with an array. What do you guys think? An array? Maybe not. Well, they say allows, so problem with this is, okay, well, we could do that with an array. Anybody have any ideas on how we're going to use this save function with the hash thing? Because there's multiple ways to do it, but I don't particularly like any of them. So I guess that's a thing. An array sounds okay. Yeah, let's use an array. Okay, cool. So let's do that, right? So our next thing is going to be save a number of stuffs to the thing, and we'll call it save, right? And the save function. So when we're saving, we want to save each array as one file maybe, or not. So let's maybe say not for now. So we'll do a create first, and we'll do a save function, right? So let's think about how we're going to do that, right? So the first thing we're going to need to do is we're going to need to actually go through this and say, all right, let's take this and create a record from it. So we're going to have an array of records that we'll be writing. We'll loop through it, and we'll write it down. And depending on the number in the loop, we're going to just hash that key and write it down, right? Is that how we're going to do this? Does that sound like a good plan? Or does that sound like a bad plan? Anybody wanna venture a little guess there? It sounds simple, which for me is good. All right, cool. So let's think about what we're actually gonna try and do, right? So our first steps here, because we've done a lot of random functions that we're not actually using yet. So the first step is obviously create the file. When we create the file, we have to create the blank record structure. Then we have to write it to the file, right? This many times. Now, if we know how to write the blank record, clearly we can just write a normal function that will do a similar thing given an array, right? So the first thing is going to be, let's try and do that. So and it's going to take an array of record structures, right? Right, and in here, right, as we've done above here, the first step is to make these two and to set the size. So we're going to copy all of this, write it down here, and we're going to copy all of this, and we're going to pop it down here. Right, for x, instead of going to 29, we're going to go to we can go to rex length, right? And then we're going to seek, instead of seeking x times 50, we're going to seek to hash of x, and we're going to seek to the origin, and then it's going to go from there, right? So what does this do? And instead of writing this this ID, what we're gonna do is we're gonna write a different ID. But first, let's check if the ID is good enough to write. So right, and then afterwards we will write the ID, and it's gonna be regex.id. The name, we need to check that the name is what they say it is. So we need to go through it and say, well, is the name actually, is the popularity incorrect? Is the name the right size? Right? And then from there, and we'll do it. Like that. Okay, cool. So then we're gonna go, actually we should have that second function where we write one at a time. Maybe I'll show you guys how to make that soon, but not right now. Right? You guys are gonna end up getting confused with this for now. So first, we'll talk about the length. So we're gonna go right, and that's the writing the name, and then the lockers is obviously it's going to be a boolean, so we don't need to care about that. We do need to care about the popularity though. Popularity needs to be 0 to 100, right? So we can go like that, and we can go greater than 100. Is line 77 a restriction from the question paper? Alright, so let's look at the question paper first, right? Up here, this is an integer limited 0 to 100. Right, so that tells you immediately that we only save stuff that's from 0 to 100, so it's from the question paper directly. Yep, and then the same one with popularity, also 0 to 100, and we know that this is 20 characters from the question paper. Alright, makes sense? Oh, and that's gonna write down everything, right? So let's just make sure we're doing things correctly. So the first thing we do is create our file stream, we create our binary writer. Yeah, we do create those. We set our file length, right? And then we kind of start writing, right? So then we go, all right, cool. We pull in some. Now, one of the things with this is this has to be a record structure, right? So we can do this test here when we're writing to the file, or we can do it when we're asking the person. It's actually more convenient to do these when we're asking the person, right? But we can just copy and paste those there when we are asking the person to fill up our record structure, right? So that was just a small mistake on my part. I didn't completely think that through. But yeah, so essentially that's how that's gonna work. So we'll make a number of these things, and it'll ask the user for a bunch of stuff, and it will save it as a record structure. We'll put it into a record structure instance, make an array of record structures, create the file, and then write the array to the file. And it should all work super easily and super quickly. Right, so the next thing we need to create is an actual, so now we need to actually do that, right? So that's the next thing. The actual thing that we need to do is in the button save. So let's go to our design. We've got some input values there, right? And input values is actually the one we're going to use. So weirdly enough, that's how we're going to use it. So please enter the number of facilities, please enter the number of stadiums. But instead of that, what we're going to do is we're going to say we're going to do it for stadiums first. Let me just read the question paper and figure out why is the locker still set to the empty array? Oh yes, that's a great question. I was wrong. This is also wrong. Good catch on that one. All right. So let's talk about how we're gonna do this. Let's look at our question paper and look at what we actually have here. Right? So we've got. So would we already have captured data from the user concerning the record to save it to a file? If the case is not so, would the blank record be saved? Yes, so the minute we create the file, we save the blank record, right? So that's what's initially in the file the minute we create it. Once we start saving other stuff to the file, that's when it changes, right? So so that's gonna be how we work with that. Okay, cool. There we go. That's fine. So use a function that'll take a record key parameter to read the relevant record from the access file. Okay, cool. Makes sense. So I'm gonna see. I think somebody sent a message. Okay, so on my honors lectures, so none of that really is important right now. Going back down here, back to this. Yeah. So let's deal with this question H before we kind of go any further with trying to write stuff, and then we'll figure it out as we go along. How's that sound? Right, we got a good set of minutes here available. So now we need the last thing, which is essentially read a single record of right. So that's something that's going to be returning a record to us, right? So is creating the blank record a way of running away from program crashing? No, the creating of the blank record is creating a file. It's writing out space in the file for you to use it properly. If you don't, it won't work. Right? Does that make sense? Yeah. Okay, so let's do a private function. Record val one is alright. So obviously our first step when reading is kind of the same as our first step when writing. We create a file stream. Right? That's always the first step when working with a file. Put a file stream down, you get 1 mark, I think it is. Right. Then we create a binary reader. Like this. I don't know whose mic is slightly unmuted there, but that gave me quite a shock. Alright, cool. Then we got that in. Now the next thing is we're gonna seek to the point and write it down. So we're gonna go fs dot. Let me read it off. Seek. Go hash this, and in here we're gonna put the key. And go seek origin. Begin. Get record ID. Right. So now we've got that. So it's gonna be. Now we have to create a spare record to return here. And why did I do that? So that makes everything have an answer, even if it's a wrong answer, right? But then we'll go set that up now. So we're gonna say, well, answer ID is to read into 32, right? We're gonna go answer name equals br dot read string. Answer dot lockers br dot read boolean. Answer dot popularity equals to br read 32. I'm going to close fs. And then we're gonna br nothing to br. And then we're gonna return this, right? There you go. Now that we return the answer, we can work with it, right? So now we can get a single record of the file at a certain key. Okay. So that gives us all the options we need. Now to actually start writing these things down. Okay, so firstly, let's go with input the number of facilities, right? So I'm gonna comment out all of the rest of the stuff because we don't really need it right now. Okay, now from here we're gonna go number of facilities. If in fact, so now actually let's do it while. X greater than 30 should be file mode creating, right? Let's just check. Maybe I did something wrong. No, it should actually be, it should not be. It should not be these. It should be read here, right? And it should be open. No problem. Right. What is greater than 30 for num that's less than 0. Right, so while either of those, we're gonna just put a message box out there and say that's gonna be a terrible thing to do actually. I'm just gonna go, yeah, so let's put a message box and say ID number of facilities exceeds the limits. Please choose a number. I'm gonna go input box. Number facilities. So why the while loop instead of an if statement? Because let's say it was an if statement, right? And then I do this and I go, oh, this is wrong. Please try again. And then he tries again, and he does the num facts, and then it just comes out, right? Because if statement doesn't repeat. What if he entered it wrong again? Right. So this will keep him trying to enter it until he listens. Until he listens. That's what you want to do there. So now, yeah, so that's kind of what we're doing there. So then what we do is we're gonna go cool. Yeah, so it is a facility record that we're using, right? Ah, yes, it is a facility record, and an ID, and you got lockers and popularity. Why is it a facility record? Shouldn't it be a stadium rec? I'm just confused as to what's going on here. Okay, it's no, it is a facility. So this is how we're gonna create the facilities. All right, fair enough. Yes. Struct ID popularity. Should I understand you at any term or rating object or need it? Okay, I actually have no idea how to do that. Yes. So we'll be winging that section. We'll be totally winging that section. But for now you know how to write to a random access file and you know how to read a single one off there, right? You've gotten that information. So I'm just gonna kind of try and put it into practice here. And essentially what we're gonna do is we're gonna create an array. Remember that array from my recs facility rec, but that I'm gonna go num facilities. Why doesn't it like me? Oh, because I have members. Oh, yeah, I was redoing. It's not about the new thing. I really need to catch some sleep. Sorry guys. And then it's gonna be num x here. There you go. Now I've got an array whole x. Then we're gonna go through each of these, get the ID, get the thing. So for y is integer equal to 0 to x next y. Okay, now let's actually just go to this. Let's use an input box to see it. And for the locker thing. How did we do that? So here what we said was, does this have lockers? And we just converted it to cbool. What I'm going to do is I'm just going to do it slightly in a better manner, and I'm going to go choice as int see input box. Does this have one locker? Nice. And we can't use that, so we use that. If choice equals 1, then it has lockers. Doesn't. And so then we're going to go x xy dot lockers equals true. So that does that, and then we've got our whole record thing. It sets up the IDs, and we're gonna send it. So first we're gonna go create. Okay, cool. So then we call create. Then we're gonna call save. What did I call the array one? I called write my array. Right, and that should 100% work out. Right, my array. My arrays. And ta-da, we have managed to write the array of record structures here. And that's that, I guess. So I have to leave you guys now. Please try it out. Please try and debug. And if you have problems, please ask Mr. Cottrell before you test. And let me know what's happening. Please use the assistance lab. If you guys do any past papers, make sure you guys go to the assistance lab and get them to go through it with you. Make sure you're doing it right or anything like that. All right. Enjoy the rest of your afternoon. I'm sorry I have to leave so early. I do have a meeting with one of my teams, so I need to go and do that. I'm glad I kind of helped you guys understand what was going on. Please pay special attention to the hash function. That's 3 marks. Pay special attention to writing the empty stuff down. That's how you write in general. As long as you understand this, you can make your own function that can write a single record at any point given a key, right? Make sure you understand the read from, which reads a single record. And then you'll be fine. You'll be 100% fine. All right, cool. So please practice. At least one every day. One past paper a day, and by Thursday you should be able to do one past paper in 3 hours. Okay, so enjoy the rest of your afternoon, guys. Have a great day. Bye bye.